Hello, my name is Matthew White. I'm one of the maintainers of some of the chaincode and contract APIs in Hyperledger Fabric, and today we're going to be formally announcing the tech preview of something myself and James Taylor, another one of the maintainers, have been working on in recent months, and this is the Rust Smart Contract API, but that is running inside a Wasm engine, which is deployed as a chaincode in Hyperledger Fabric version 2. So this is the main documentation homepage, and go here to have a look at some docs and look at getting started and see the prereqs we need for getting started. So what I wanted to do just in this video is just to run through the first getting started, the quickest one, just to give you a flavour of how things work. So the diagram here just shows a little bit of context of what we're going to be doing. We're going to be starting a Docker container which contains something called microfab. Just a quick link to microfab. This is a containerized Hyperledger Fabric which is perfect for development environments, very quick to start, single Docker process, but is a full Fabric version 2.2 inside. So we're actually going to be starting a slightly customized version of that, and customized specifically because it will contain a chaincode builder that will understand the kind of Wasm tag for chaincodes and launch a Wasm virtual machine and run the Wasm binary that we have given it. This Wasm binary will have come from us compiling Rust code. Rust has got a great ecosystem for Wasm development and is also a very good language for writing code which you need to be correct, you need to be safe, because it's very strong compiler, the very strong borrow checker, and the whole type system in Rust is well suited for this type of development. And we're going to be installing that Wasm binary just using the regular peer commands that you use with Fabric, and just invoking it as a regular chaincode. From the perspective of the peer, once we've got everything installed and working, the peer is seeing another chaincode. It's not identifying it any differently, it's responding exactly the same. So it can be used with existing peer commands or SDK applications or whatever you wish. So there's a number of things we'd have to install first. We'll need the Rust toolchain. Stable Rust is sufficient. Don't need the nightly version. Do need the Wasm target as well, so you can easily add that with that command. And you'll need to get sort of Git and the usual development tools installed, and also the Hyperledger Fabric version 2 CLI binaries. If you don't have those already, then here's the curl command to be able to get hold of those, and you need to set up the path and the Fabric config path appropriately for wherever you've installed those two. I've already got those on my system, so I'll move on to starting the smart contract. Easiest way is probably just to clone the main repo, which is this Fabric Contract API Rust, and then we can actually get on and build the code. So let's get on and do that right now. Go to a terminal, move to the Fabric Contract API Rust, and we have just a simple file setup just to issue Wasm, and actually I think it's already been built, so that's very quick. So just to show you that we have here basic contract rs.wasm is the contract, very basic contract that we've compiled into Wasm bytecode from Rust. We'll show you more about the contract a little bit later, but let's keep going and get things up and working. So one of the first things actually we need to do now is to actually start microfab or a specialization of it. And in a separate terminal window here, because is easier, we'll just set up a configuration, single organization, single channel, nothing particularly complex there for demo purposes. And let's start that going. So this is perfect for development scenarios because of the speed of its starting. If you're familiar with starting other ways of doing Fabric, the full Docker container environment or cloud, you know it takes quite a bit longer. But that's now up and working quite happily. That's very good. So one thing we need to do is obviously interact with that, and I've got my peer commands set up here. But I do need to have the crypto material, the identities, etc., from that particular Fabric environment set up. And I'm going to extract those with the curl command from microfab, which is this part here. And then this is just a Node.js tool that we've written, which just helps to pull out the information and format it correctly, and gives us a couple of environment variables that we can set so we know the peer command is going to work. For anyone who actually used Fabric before, if I just list what's in that directory, that structure would probably look familiar. Okay. So we've now got the identities ready. We can actually start to do packaging up the contract. Now we need to package the contract in the new manner of Fabric version 2, which is as a TGZ file with a manifest, and that manifest specifically has to identify this code as being Wasm, so it uses the right builder. And being developers, we've got a helpful script here to do that. This is really just a scripted version of the standard peer commands, but making sure that metadata tag is correctly set. So we're just packaging up the TGZ file there from the basic contract, and we've got that all packaged up. Right, so now we've got it all packaged up, we're now into effectively standard Fabric commands, Fabric ways of working. We're installing the chaincode package. It's generally easier to capture the package ID here. So you can use it in later commands. It just makes things a lot more straightforward, especially when you're cutting and pasting existing commands. So we now need to approve that chaincode definition for my organisation. There's only myself here, so that's quite easy to do. And then we commit it as well. So let's commit that here. Again, all very quick, all very local. And so now we have a chaincode that's running that has come from Rust and is running in a Wasm VM. So let's actually go and invoke a transaction function on that. Peer chaincode invoke here, and we're issuing the asset contract create asset function. We'll go and have a look at that in a moment. We're issuing it with two arguments, 007 and bond. Paste the query command here. So this is again asset contract read asset value, passing in a single argument this time of 007, and it's telling us bond. So we've gone to the ledger, put an asset in, and then queried it and got the result back. Okay, so let's go and have a look briefly now how the chaincode is written that does this. And this is VS Code with the Fabric contract API REST here just already loaded, and each contract is a separate crate. So I've got here basic contract RS. There's a couple of other examples just above it, and this is our main contract. Just expand this on the full screen, and we're pulling in the appropriate Fabric contract modules, and we are creating a structure that represents our asset contract. Now the API that we put here is also something we're really looking for feedback on, because this is an evolution of the contract API that was seen in the Java chaincode, the Node chaincode, and Go as well. And also brought in ideas from the proposed Ledger API to really try and lift the programming interface to a high level, so people can focus on the business logic of their contract, focus on actually the technical aspects of who has to have ownership of what and adding things, rather than some of a lower level minutiae of data manipulation and worrying about error handling, excessive error handling, etc. So we've got the contract implementation has been marked here with that Rust macro. And we've got some transaction functions here. Let's just look at the two we've actually already called. So here's the create asset, and we take the asset ID and the value, so that was 007 and bond. We're accessing the world state, and we are creating a new asset with the ID and the value. Here's the actual create that goes and issues the call. So under the covers, that will have gone over to the peer and issued the put state request. That was logging out OK. So that's submitted. That's a transaction submit, which is giving the indication that we need to actually submit this and send this to ordering. So the read asset value here, the query that we issued only has to be evaluated. That doesn't need to be ordered. Again, similar, we're creating the world, accessing the world state, getting hold of a collection which represents that. We are asserting that the asset exists, and again, the error handling here is very straightforward, partially helped by Rust's match syntax. Does this asset exist? If it does, okay, we can go ahead and retrieve it. Otherwise, we can actually return a meaningful error, and we'll try to lift the API here so you can actually now work in terms of your business domain rather than a sort of a lower level APIs. Okay. So I'm just going to go back to the homepage documentation. Let's go back and show you what we've done. So we created microfab, we created within that a Wasm VM when we installed the Wasm chaincode. That Wasm chaincode was started in the VM. That chaincode itself came from Rust that we compiled to Wasm, and we invoked it from the normal peer CLI commands, but could easily have done it from Node.js client apps as well. So give it a go, see what you want, see what you think, both on terms of the whole concept of using Wasm as a chaincode container, also the Rust API, sort of this contract and ledger approach to doing things. We'd like to push that into the other languages if possible. And what we haven't really touched on is actually the boundary between the Wasm and the host and the guest. We've actually got a defined API in there, so if anybody wanted to take a different language that compiled to Wasm, you could write that and interact with that kind of API directly to actually have a different language entirely running your smart contract. Okay. So API documentation is here, standard Rust documentation. And if you click on the GitHub, this is going to go to the main GitHub repository, and please go and look at issues. If you've got any questions, comments, etc., just raise an issue here. Quick shout out to Ian Weiss, who has also committed a couple of things to us so far, which is great, and raised a couple of issues, so we do need, which is really very good and helps us go forward. So please, go and take a look and raise some issues, and look forward to hearing from you.